Good morning. This is Dr. Vivek Bhatnagar. Today I'm delivering the second lecture for the software engineering. So in this lecture we will be studying about the various process of software engineering, discuss about the SDLC models, going with the various kind of model which are to be there. The first would be discussing the waterfall model. Then I'm moving across with the iterative model, prototype model, and the spiral model. So these are the content we will be covering in this lecture. So first of all, as you already know that in the first lecture of the software engineering, we might have understand about how the problem solving activity that can be considered for the analysis of any software problem. So while if for that process, I would like to go with various problem solving activities that can be solved. Firstly, secondly, if this is a process so-called software engineering, then for the engineering, how the problem can be analyzed and it can be solved. So there may be so many techniques, some methods that can be there so that the producing result, some well-refined notations and what kind of methodology we can go with it. So it means there must be some methodology so can we devise that how to solve a fundamental problem. So for that process, if I am applying the principles of software engineering, then all the way the customer will come along with some problem, right? For example, I'm taking the example for the computer science. So we are dealing with the same process, theory as well as the practical applications. Same electrical engineering is there, then it is meant for uh, say physics is an elementary part, then electrical engineering for the theory as well as for the practical. So for example, if the computer science is to be there, then it is meant for theory as practical, then software engineering is to be there so that we can go with the theory as well as the practical aspect of the problem. So it means for that finding to solve a customer problem, so we need to devise some tools technology to solve a particular set of problem. So likewise, if a particular set of problem that can be solved, then there must be some development process so that we can execute a various kind of work and we can do the work in the various phases. So likewise, so many definitions are to be there. So, so in this definition, I have so many things like how to achieve the methodology to achieve a software which is of high quality software. Secondly, it could be within a given budget and it should be delivered it to the before the deadline which is to be there, right? So we wanted to go for a solution which is optimal solution, that is the low cost, high quality and the small cycle of time. So if I am devising the process for the software engineering, then of course every customer or the client would need to have the high quality software within the cost and stipulated time period which must be there. So but as so many processes we are talking about, so this time if met with the criteria for the software engineering, we need to define a process that could be, you know, a strong process, right? So process is a method of developing a software. So likewise, I wanted to make a process which must be adapted. We need to improve the earlier crisis problem with the software. So somehow we want to improve the success ratio for the project, right? So if this could be there, so I need a better hammer or I need a better process so that I can execute it. So execute a good process. So that is the way I can deliver the process in a good refined manner. And most of this process is called SDLC, which has been adopted by or acknowledged by the world leader or the throughout the world, we adapt the same process. So many definitions of the software are to be there. It is a systematic approach for the development, operation, maintenance, and retirement of a software. So it means we have learned one thing, that while we decompose the problem into the various part, then we can work accordingly to the different kind of problems, right? A bigger problem is there, then we divide and convert technique we can apply and we can achieve various phases can be done. In the various phases, we can break the problem into the various part and work accordingly. This is what we are doing in the software engineering. We are working in various phases. So while we try to work the same problems or the solution getting approach, okay, decompose, we got to know that in decomposition we are refining the problem. Then obviously the software engineering might be facing some problem. The first is the problem of scale. As the problem of scale, the name is to be there. uh, it is the same set of rules and principles should be for the small project, and same set of rules should be for the large project, but in the real time, in the real sense, it is different. So likewise, if I would like to know how many students are there in specific class, I can count how many students are there in a specific class. But on contrary, if the same set of principles should be applied, then how many students are there in a one university campus in which there are various departments which are to be there? Then for that various department, I have to deploy different set of rules which can be there. So in the real sense, this could be more difficult, that for a smaller project the rules are different, and for the larger project the rules are something different. So this was the first problem which was done with the problem of scale. Then second, it is costly. It is costly. Yes, of course, it is costly because all the time the labor is to be involved directly. So when the labor is to be involved, it means it is labor extensive. So what does it mean, the extensive? Mean one person working on one project for how many months it is to be there. So that's why all the time the labor is involved directly. So somehow it is costly. On the third problem, the problem of consistency. In the consistency, we would like to have on every cycle, it should give us the same result. So, but what the customer or the client want, the client is seeking for a solution which is optimal solution, that is the low cost, high quality, and the small cycle of time. And every cycle, it should give you the consistent result. So for checking out the consistency, likewise, I just quote one example for the branded tube light versus the Chinese tube light. In the same parameters, uh, most of you, most of we be using a tube light which is of a branded tube light. So because of the consistent criteria for company called Osram or Philips, right? So they have a consistent criteria for that tube light. It will blow 800 hours. It will blow. Otherwise, the warranty of 1 year is to be provided to the customer so that they can replace it. On contrary, uh, the because the Philips company has fixed a certain consistent criteria that it will blow around 8,000 lumen hour. Otherwise, you can replace the product within 1 year. On contrary, the consistency of the Chinese tube light is not fixed, right? So it can be fused in 1 day, it can be worked on more than 1 month, right? So the consistency criteria for the Chinese tube light is not fixed. Okay, so this was just regard a problem. The software engineering itself might face so many problems. Then we move upon a certain aspect, okay, in what process we wanted to go with various models. So this, if I would like to devise the model for the software engineering, then for the models, it could be termed as the pictorial representation of anything which is termed as a model. And for model, we need to draw pen and pencil to draw a picture for the same. So while making a model, it means I am seeking solution to that particular problem, right? And of course, I need models in the three sense which is to be there. The first is where the implementation is not possible, where it is very much time consuming, and where the actual implementation is very much costly. So these are the three senses in which we need to have uh, go with the models. So how we go with the software engineering model so that the well documented process we can define in a predictable manner. So once we define in a predictable manner, so it means so many phases are to be there, and a life cycle which typically includes start with the requirement phase, design, coding, testing, maintenance, etc. So these are kind of phases in which we can work and we can deal with at least the small, medium, and large kind of project, right? So likewise, when we started to execute any process, once you see any book which is so-called textbook and reference book in which various model are to be there, we have to have start the model advent from the waterfall model as first model. But before that, how the process is to be executing. So at that time, the process is to be executing like there was a model of the two-step. So in the two-step model, we have to build some code and fix the code. So while building the code and fixing code, in between, there are so many, so many things which are not to be, in a good manner. Like we were unable to deliver the medium type of project. We were unable to deliver the complex problem, right? So it means because it was a two-step model, and at that time we were just delivering only this small level of project, because in that process the process was not good and it was there only for this small programming exercise which could be there for 400 to 500 lines. So as far as the line exceed, the model fails. It doesn't give the result. So many times the factor increases, the complexity factor arises, and we were able to deliver only the small segment of project. So what happens that time, the the success ratio has decreased tremendously, because at that time no trained number of engineers was there, no structured design room were to be there, right? So we were not able to maintain that project at that time, because that time the process was not good. So then after so many year passed, in 1970 onwards, some scientists they invented this called waterfall model, right? So it is due to its cascade. It terms as the various phases has been defined. In the various phases, we work according to the various phases, and start due to its cascade. It is called the waterfall model, or uh, the likewise the waterfall, you never have seen the water coming from downwards to upward. It would always come from the uphill to downward. So likewise, as the diagram is to be there, the diagram depict how due to its cascade it is called waterfall model, in which various phases are to be there. Start with the requirement analysis, design, coding, then testing, and then operational maintenance was to be there. So it was the first model in which uh, when the phase X is over, you can move to the another phase Y. It means there was an assumption that you have to complete one phase so that we can move to the another phase, that is Y. So at that time, but in the real time, it is not possible. It means how should I tell to somebody that once the requirement phase is to be complete, the first it's to be complete, then I can move to the Y. Then how to tell to your customer that you should tell your requirement only once, I will able to freeze that, then I can start working. But in the real time, it is not possible. So it means such kind of unrealistic approach, when you have to define the requirement on a very early manner. So such kind of model, how could I deliver it for the customer who are talking about a project of large scale, talking about a project of small scale even, right? At that time, small, medium, large, we are not able to complete any project in the approach for the waterfall model. So it was very difficult to assign it, because nobody will declare to tell the requirement all the time beginning, right? It has to, as so many times it can be changed. So but in waterfall model there was some assumption that the model is does not accommodate any kind of change. So the thing is very clear, it does not scale up for the small project, even for the large project. But so it could only be possible with a project which have simple solution with strict deadlines. Like I want to automate an existing manual system, then I can go with the waterfall model, right? So because the real project are really sequential, so we cannot depend upon the waterfall model for the small, medium or large project. So what to do? Still the success ratio is still, it is not up to mark. We want to increase the success rate of the project. Then there are some changes when another model. So likewise, once we are studying so many models, we are moving from left. Once we are moving from left to right, so it means we are upcoming to go with small, medium, and large category of the project. So the second approach in the iterative enhancement model, the earlier model, we were not able to go backward. But once I am talking with the iterative enhancement, it means I have a provision to move backward in this model. Likewise, in earlier, we were just delivering a process once a phase one is to be over. I can move to the next phase, that is the why. But in iterative enhancement, we are able to uh, uh, talk with the developer and the customer and then just prioritize the requirement as the customer want. Secondly, so many requirements that are to be possible and it can be prepared and it can be mentioned in the SRS2. Likewise, we have a provision to move backward. So it means we have a criteria to add so many others requirement which are to be there in the iterative enhancement. So it means client does not have to pay together in this model. Secondly, it can be deal at least for small project around. And third, the customer or the client does not have to pay together. When the requirement came, they start working. Then after, there is called prototype model. In the prototype model, same, uh, likewise, we have a provision to change the requirement so many times unless until my client or the customer is not ready, right? So prior approval of the client is a biggest motto while I'm talking about the prototype model. So likewise, as you can see, the analysis after analysis, we have a change criteria for the requirement unless until my customer or the client is not approved, then I cannot start with the design. So once it should be the criteria should be met from the both parties so that we can start with the work. For example, uh, the map of a house is to be there. In the map of a house, this map this map is to be reviewed by one of your family member. Unless until the map is not approved by your dad, the requirement criteria cannot met. So map is just a blueprint of any house which is to be made, right? So unless until it is not been approved by the customer or the client, then the architecture is not able to start the design. So this is how so many times it can be changed. Likewise, somebody make a map of a house, say the map is to be reviewed by one of your family member, and they said my dining room lobby should be small, my bedroom size should be say big, like this. So it will again go to the architecture, it will again change it, it will again shown it to you. Then there are some reviews. Unless until you are not finalized, it cannot start with the design. So this is how in the prototype model we have a provision to change the requirement so many times unless until the customer is not approved, right? So in the prototype model, it can be there for the small as well as for the medium type of project, right? And secondly, the client can actually feel with the system, that is the feedback is to be there in this model, right? So what to next for the complex structure which is still to be there? And for the complex structure there must be a model which is a complex model, right? So as far as for the large project, so many time, every time the Barry Bomb invented incorporate the word called risk in the project. So making a project is always a risk. So still now I am taking your class, earthquake may or may not come, right? So any negativity that may hamper the cost, schedule and quality is termed as a risk. So he analyzed that a risk is to be there while I am talking about any project. So likewise, the Berrybaum invented this model called spiral model. The spiral means there are so many loops. So exact number of loops are not fixed. The loops are depend upon project category to project category. Likewise, there are four quadrant in this spiral model. In the first quadrant, we will go with determine objective, some alternate solution to that particular problem set, and it is the innermost cycle in which we can start with according to the phases. While moving across with the second level, on the second quadrant, we will able to identify so many alternate solution to make a prototype to that problem. So while the prototype is to be reviewed in the second quadrant and analyze the risk factor, which is to be the mandate because I am making dealing with a larger project. So in earlier discussed model, we never analyzed any kind of risk analysis. So in the spiral model, we analyze the risk factor. So while moving across with the third quadrant, in the third quadrant, we are able to get to know so many requirement validation, verification criteria and develop the product for the next level. So when I am going for the iterative to the next level, it means I would like to make another review for the same. So while in the third quadrant, it will move and the iterative circle as it is to be there developed for the next cycle so that most of the errors in the validation that can come upon and we can rectify so many other error. So in the fourth quadrant, we're able to get to know the plan for the next level that can be achieved. And these loops are not fixed that are depend upon the project category to project category. So in this model, we have the systematic stepwise approach. And sometimes this model is also called meta model because we in this spiral model, we have discussed all above discussed model we discussed the innermost cycle which depict a life cycle. On the second quadrant, it shows like prototype. On the third quadrant, it behaves like the iterative. So all properties of above discussed model, it is also called spiral model. And this complex model is meant for the large project which can be used inside the industry, and it has a systematic stepwise approach. So these are the four sectors, the four quadrant which I am discussing it, and it is also like the like planning, risk, development, and the customer evaluation, which could be the the four quadrant which we are using in the spiral model. Likewise, as I told you, the objective, the constraint solution, the risk reduction, which is to be there. Then after validation, we are plan for the next cycle. And on the next cycle, are we able to getting to know about the risk factor? And finally, the stage is to be reviewed and the decision is to be made for the further cycle. I would like to revolve one more cycle for the spiral model or not. Like, so this is just of an example how we used this spiral model inside the company. So these are some advantage because somewhere it is a risky. Now somewhere it is costly, right? But this model is widely used for the complex structure or the large segment of project. And it has a systematic stepwise approach. So these are the three, four foremost model which are there in the syllabus and which we might have discussed with you guys, starting it from the built and fix and end up with the spiral model. So can I have one genuine question to the audience? At last, you will get the answer for the same. The selection of the model is dependent upon all of the time. It is the requirement, it is the development team, it is the user or the some risk which are to be associated. So always remember one thing when we select for any life cycle model of the SDLC which could be there, we need to have these all four factors, right? So this was all for the today lecture. For the any doubt, you can go with the video and in the doubt class, you may ask if you wanted to ask anything. Thank you.